Hello everyone, and welcome to this tutorial from BlenderCookie.com. My name is Jonathan Williamson, and today I want to take you through a little bit of Python scripting in Blender. And we're not going to get into too many nitty-gritty details or too much of the actual Python language, but what I do want to show you is a quick look at how we can automate some tasks in Blender. Oftentimes when we're working, we'll do a lot of repetitive things, whether that is duplicating the object and scaling it a whole bunch of times, or adding the same modifier and applying it to 100 different objects. Whatever it may be, there's a lot of times where we would like to speed something up because it becomes repetitive and it becomes boring and it's not very efficient. So this is a perfect case where we can use the Python scripting within Blender. If you're not familiar with Python scripting, basically what we're able to do is to run any tool, or mostly any tool, within Blender via the Python scripting language right inside Blender. So this just gives us very quick access to all of the backends of Blender, allowing us to do a lot of different things. Now for this tutorial, I'm not going to be diving into the raw basics or the syntax of Python. I am going to keep it fairly simple, and explain what I'm doing at all different stages and try and give you some insight into it if you're not familiar with it. But I do encourage you to read up a little bit on Python. This is something that I'm still learning myself, and personally I recommend codecademy.org. They've got a really awesome Python course that really explains all the basics without assuming anything. So if you have absolutely no programming experience, no Python experience, then it's very, very suitable for you. It's actually where I've been learning primarily. So to get started, what I would like to do in this case is assume that I have 100 different objects and I want to apply a Subsurf modifier to it, or increase the level to 2 on that Subsurf modifier, and then apply it. So this is not, a very long thing to do. I mean, I can simply go to Add Modifier, Subdivision Surface, increase the level to 2, and click Apply. But if I wanted to do that 100 times on 100 separate objects, it would be, well, cumbersome. So what I'm going to do is I'm going to automate all of those steps, the adding the modifier, increasing the level, and applying it in Python. So what we want to do is, first of all, note how I've got my interface set up. So I have the text editor over here, which is where we can write our scripts. I've got the Python console down at the bottom, where we can look through, access different commands within Blender's Python API, and do all kinds of other things where we can test commands, etc. I've got the 3D viewport just so I can kind of see the end result of what I'm doing, along with then the modifiers displayed over here. And then finally, I have the default info section, which is normally it will look like this, but if you just go up here and drag your mouse down, you can see this. This is actually basically just a hidden panel behind the info bar that just allows us to see the last command we've run. So you can see here we've got modifier stuff. So if I click, go in here and add modifier, then we can actually see the command right there. So this is the actual Python path for what we want to do. And we're going to be able to use this to kind of see where the commands are and what we want to do. So let's just delete the modifier. And the first thing that we need to do is tell the text editor that we are working in Python, but more specifically that we are working in Blender's Python API. In other words, basically Blender's pathway between Python and the Blender's toolbase. So the way that we do this is we import BPY. Now you will notice that I have syntax highlighting on, and the colors are slightly different because I have my custom theme. This is the CG Cookie theme, which you can, if you want a link to it, just ask in the comments and I can give you a link, or you can find it from a variety of different other places, including the CG Cookie GitHub repository. And if you don't have syntax highlighting on, it's just this little button right here at the bottom of the script editor to enable it. This just makes it really nice because that way you can, get some indication of when your script is correct and when it is not. Okay, so importing BPY just tells the text editor that, hey, we want to import Blender's Python API such that Blender can understand our Python commands. Or not necessarily understand our Python commands, it can understand those Python commands that are relative to Blender, such as all of these up in here. So the first thing that I want to do is I want to add a modifier. So we can see that our command up here to add a modifier was this one, bpy.ops, which stands for operator, .object.modifier_add, parentheses, type equals, quote, subsurf in all caps, end quote, and end parentheses. So if we merely type that in to bpy.ops, which again, ops stands for operator, and an operator is basically any tool that we run within Blender, including any one of these and a variety of other things. So bpy.ops.object, because we're talking modifiers belong to the object, so it's going to be object.modifier underscore add, and then we want to do an open parentheses, and the type of the modifier is defined by type equals quote. We can do either a single or double quote. The main thing is just be sure that they are consistent. So if you use a single quote in the beginning, then you want to use an end quote, or a single quote in the end. We'll just do a single quote, and then in all caps, it won't work if it's not all caps. Just do Subsurf, closing quote, and closing parentheses. And now, if we want to run our script, this will add a Subsurf modifier to our object here. So we can run our script either just by clicking Run Script here, or by pressing Alt-P in the 3D view, and let's go ahead and test it. So if we press Alt-P, there you go. We can see that we have a Subsurf modifier automatically added to our object. Now, this is very important though, is that this object is selected. Because if this object is not selected, let me just delete that modifier, and I will deselect this. Let's run it again. And in this case, it still added it. But it still added it because my cube is still my active object. So let's change this a little bit. Let's delete this again. Let me zoom out. I'm going to select the camera. Because remember that in Blender, and this becomes very important when you start doing scripting stuff, is that there's two kinds of selections. There is a selected object, and there is an active object. And an active object is both selected and active, whereas a selected object is only selected. And this sounds kind of weird, but it's very true, and it's also very important to know because anytime you run a script here, or anytime you run an operator that acts on the object, it's always going to take effect on the active object. And so whatever active object that is what's going to get the script. So now that my camera is the active object, and I press Alt-P, you'll notice it doesn't do anything because the camera can't get a Subsurf modifier. So it just doesn't really do anything. So if I now select my cube and run it, then I get my Subsurf modifier. So that's just something to be aware of if things aren't working as you go along. Okay, so this is the first step. And obviously, do keep in mind that when I'm doing this with just my single object here, it's just an example. Because what we're going to do in a little bit is we're going to show how to actually do this on, say, 100 objects. But first, we need to learn how to do it on a single object. So even though writing out this is no faster than doing this manually, it will be in a moment once we finish everything. I just, don't have 100 objects in my scene, and this way we can stay very focused on the single object. Okay, so let's just delete this because we're going to be adding this a bunch more times. And what I'd like to do now is go ahead and take that Subsurf modifier that I've added, and I would like to increase the levels on it to 2. Because, for example, one thing that we might be doing with this little script, because this is actually a very practical script that we're writing here, is very often when I'm working, at least, I want to start with a polysphere-like object. A UV sphere has a lot of triangles and doesn't have very good geometry for starting an object. Neither does an icosphere. But a sphere, as far as the shape goes, is a great starting point for a lot of models. And so generally what I'll do in my own workflow is I will take a cube, I'll add a subdivision surface modifier, I'll increase the level to 2, and then I'll apply it. Because that then gives me enough geometry and nice topology to then start any kind of different model, whether that's a skull, a torso, any number of things. And so this is the way that I would do that. So in order to get that to level 2, let's go ahead and add to a new line, because remember that Python basically starts from top and goes down. And so we're just going to add a new line, and in this case, we want to increase the levels. So if we just scroll up here, we can see that the way that was done, and we can see it's via bpy.context.object.modifiers subsurf, so it's the name of the subsurf within brackets, not parentheses, dot levels equals 2. And basically what this is, it's saying, it's accessing context, so it's saying, hey, let me look at the things that are attached to this specific piece of data. So I'm not creating new data, I'm modifying existing data. So let's go into bpy.context.object.modifiers, and then it is a bracket and the exact name of the modifier. So this is going to be, in the beginning, this is going to be very hard coding. And just be aware that if you have an existing subdivision surface modifier on, like this, and we finish writing this out, and then we run this, it's actually going to increase the levels of this one because we're basing it on the exact name of Subsurf. Because if you don't have a Subsurf modifier on an object, or you don't have one named Subsurf, the default name is always Subsurf. But if you add another Subsurf modifier, this is subsurf.001. So what we want to do in the beginning is we're just going to hard code it. But towards the end of this tutorial, I'll show you how to actually base it on basically if the modifier is a subdivision surface type, then we can adjust it. So in this case, let's just hit parentheses. And I like to use full quotes. Anytime I'm talking about a name, I like to use full quotes. Anytime we're talking about types or data or anything like that, I use single quotes. I believe that's fairly consistent with the general Python practices within Blender. It may not be, but that's what I like to do at least. So I'll use a full quote, and I will say subsurf, which is a capital S. It needs to be exact. Closing quote and closing bracket. And then it's dot, let's see, let's just scroll up here. So we can see it's dot levels equals 2. So we're taking, basically we're finding within our object, we're finding the modifiers, then we're finding a modifier with the name Subsurf, and we're increasing the levels on that modifier to 2. So if I now run this script, we can immediately see we have a Subsurf modifier and the levels have been pushed to 2. Sweet. So the next step then is to apply that modifier. So if we scroll up, we can see when I applied it, and it was ops.object.modifier underscore apply rather than underscore add, and then it's apply as equals, because when you apply a modifier, let's just take a look at this, you can actually see, you can't actually see it in here, but there's actually 2 different ways to apply it, which is as data, and I believe as something else, but we don't really need to worry about that. But we're just going to mimic what we see here for the time being. So it's bpy.ops.object.modifier underscore apply, parentheses, and then apply underscore as equals, and by the way, you can or cannot use spaces here. It doesn't really matter. The main thing within your code is just be consistent. So I personally prefer to use spaces between anything like this simply because I find it more readable. So apply as equals quote data in all caps. Anytime you're referencing, in this case, well, data, but whether that is a type or data or anything like that, it's generally going to be in all caps. And later down the road, you'll be able to use this as a way to check that. And in fact, let's actually do that right now. So let's assume that we don't know what this is. So let's just scroll back down here so we're not relying on this, because let me show you how to use the Python console. So the Python console is an incredibly valuable thing because it allows us to not only run commands, but find the commands. So for example, if I was looking for apply modifier, I know that it is an operator. So first of all, since it is a Blender Python command, I'm first going to type in bpy dot, well, we don't know yet, but let's just hit control space because this allows us to autocomplete. So we can do bpy, and within bpy we can see app, context, data, ops, path, props, types, and utils for utilities. And in this case, we know that it's an operator because we're acting on an object. So let's do ops dot control space, and then we can see everything in here. And so then there's all the different things we can apply to. And in this case, it's an object. So let's go and type in object. We can do control space. It'll autocomplete. And then period, control space again. And we can see all the things within object. Now, in this case, we just happen to know that it's modifiers, but we can scroll all the way up here. And there you go. You can see all the different modifier types. So in this case, it's modifier underscore apply. So we'll do modifier underscore apply. And then we can see it autocompletes the command, and it's parenthesis underscore or parenthesis apply underscore as equals data, comma, modifier, for it's basically asking, okay, which modifier do you want to apply, since an object can have more than one modifier, and then within the quotes will be the name of that modifier. So we're going to apply it as data, then it's a comma, and then we want to call the actual modifier that we're going to use. In this case, we are going to, again, use the same one. So it's going to be, again, in parentheses, or excuse me, not in parentheses, but in quotes. It's going to be Subsurf, because that's the name of our modifier. And then a closing parenthesis. And now if we run that, you can see it automatically adds the modifier, it changes the level to 2, and it applies it. Very cool. Okay, now just be aware that we don't want to undo this, because if we undo this, we're also going to undo our code that we just put in. So let's just simply hit X, and then we will add in a new cube, because we now want to take this a step further. So we now have our script. This will add our modifier, it'll change it, and it will apply it. But what happens if we say duplicate this object, and we select both of these, and we run our script? It only acts on one of them. And this goes back to what I said in the beginning, where when running operators through Python, it acts on the active object. So even though I have both things selected, it only runs on one of them. And even though it may seem like it'd be nice, you cannot have more than one active object. So what we need to do within our script, if we want to run this, because again, remember that we're writing this script with the assumption that we may be applying this to 100 different objects. What we need to do is we need to find a way to grab all of our selected objects, take one at a time, make it active, run this section of the script, move to the next object, make it active, run this section of the script again, and do that for every single active or every single object that we have selected. So the way that we do this, and let me just delete this and I'll add another cube. The way that we do this is we first need to use, we first need to look at where are our selected objects. So first of all, let me show you how to find the selected objects. And this is starting to get a little bit more into the depths of actual Python, and so I don't want to go too far, and I'm only going to kind of scratch the surface here. And this is again where if you don't have any Python experience and you're interested in this, be sure to go ahead and study actual Python via Codecademy or many other books. I know that I personally have been recommended the book Dive into Python, which is a free ebook online. You can if you just Google Dive into Python, that you'll find that really, really quick. There's all kinds of different resources out there for learning Python. Because remember, we're not working in Blender specifically. We're working within Python using Blender's Python API. So we're using Python to access tools within Blender. So as long as you know Python, you can script in Blender. Okay, so the first thing that we need to do is we need to find all of our selected objects in Python. So the way that we do this is by using or finding the list. So basically, any group of objects is stored in what's called a list in Python. Now, you don't really need to know that for this case, but it'll help you kind of understand what we're doing. So first of all, the list of objects can be found in bpy.context because we're basically looking for, what exists. We're not creating anything, so we're not using an operator. We're looking at, hey, what is within our scene? So we want to look in context.selected objects. So if we just type in bpy.context.selected, we can see we got all these other things, and it's not selected or editable objects, but selected objects. So let's just do selected_objects. There we go. And if we now hit Control Space again, it'll autocomplete to the next one. And now you can see that within this, there is 0 and 1, because each object that we have selected is given a single index. So indexes in Python start at 0. So one of these objects is 0, one of these objects is 1. So if I just say select another object, now I hit Control Space. Let's just delete this once and hit Control Space again. There you go. We can see now we have 0, 1, and 2. So we have 3 objects selected. And what we can then do is we can use what's called a for loop to actually go through each of these objects. Now, this will make more sense in a moment, but let's go ahead and implement it in here. So I'm just going to write this out, and then I'll go back and explain it. So what we're going to do is we're going to use a for loop. So it's for, and then the for loop uses a variable. So first of all, let's define a variable. In this case, let's just use obj. So a variable, and I'm trying not to get too ahead of myself because I know that some of you guys will have no experience with this, but a variable is just basically a word that we can assign a value to. That value can be a word, or what's known as a string. It can be an integer or an actual whole number, or it can be a float, which would be a number with a decimal point. So in this case, it's just, we're going to be assigning one of these objects from this list to the word obj. Now this will make more sense in a moment. So let me just go ahead and finish this, and then we'll go back. So for obj in, so basically I'm going to say, look, within this list, which this list is bpy.context.selected objects, : So for objects within this list, I'm going to do what's ever next. Now, anytime that we want to do a loop, or basically use an indented block, it tells Blender that it tells Python more specifically, that for each object within this list do what's ever next. So what we need to do is we need to go ahead and indent this one. So we can just put our cursor here, hit tab, go back, hit tab, go back, hit tab. So this then, for each one of these objects, will run this indented block. As soon as it goes through all of these objects, then it will go on to what's ever the next piece of code, which in this case is nothing. Okay, so let's just go ahead and show this real quick, or to make more sense. At the moment, this actually won't do anything. So sorry if I'm getting a little bit scattered here. Remember that we need to do two things. We need to find our group of objects, which is this. This is our group of objects. We need to specify one object at a time, which we do via this. And this can be anything. This could be I, this could be var, this could be obj or object. It can be anything. In this case, I'm just using the abbreviation for object for obj as my variable. So the reason I say that can be anything is to show that obj is not important. That's just what I've chosen to use to represent these. So we have our list of objects, and now we need to tell Blender to one at a time, pick one, and then make that object active. So the way that we make this object active is by calling basically the active context and assigning it to this. So in this case, what we can do is bpy.context.scene.objects.active equals obj. And again, it equals obj because what happens is as we go through this list, it first finds the first object within the index, which is 0, assigns it to this variable, obj, and then goes through the indented block. So when I say bpy.context.scene.objects.active, which is the command that you use to basically assign the active object, I'm assigning it to that first index. So this way, it's going to go through one at a time, make the object active, and then continue on to run this. So if I simply run this now by pressing Alt-P, you can see I get an error. So that's, of course, to be expected. So let's see what our error is. So in this case, what I'm doing is, since I'm on OS 10 or Mac OS 10, I'm using the terminal. Let me just bring this down to where you can see it. Let me just run this again. So I'll press Alt-P, and you can see Python script fail. Look in the console for now. So I switch back here, and we can see attribute context. Object has no attribute selected object. So in this case, I probably just have a typo. So if I go in and I look, and I see bpy.context.scene.objects.active, or excuse me, it's right here, bpy.context.selected object. This should have an S, so selected objects. If I press Alt-P now, then you can see it's run on each one. So it's gone through, it's found my list, it's gone through one at a time, first picking, we'll just say this one, it's made that object active, it's then run the subsurf, then set the subsurf levels, then it has applied the subsurf, and then it's gone on to the next object, and it will do that for every single object within the list. So if I just delete this, I add in a cube, I duplicate that cube, and then we'll just repeat that a whole bunch of times. So now I have a bunch of cubes, I'll select those, and I press Alt-P. It then runs through and applies that on each and every one of them. Cool. So now my script is pretty awesome in that it works for lots of different things. But I could go ahead and take this a step further. So right now, our code is a bit messy because we've got this bpy.context.ops everywhere. So let's clean it up a bit. Remember that we used a variable right here, and that a variable is just basically a word that we are assigning a value to such that we can then reference that word in order to use that value somewhere or another, or reference that value. So what we can do is we can take a shortcut here. Since we've used bpy.context and bpy.ops multiple times, why don't we simply say that object equals bpy.ops.object. Then I can simply go down here, delete that, and delete that. And now what's happening is when I say object here, it's actually bouncing up here and saying, oh, look, object actually equals bpy.ops.object, and then it's moving on to the rest of my command. So running this is the same thing as running the full thing. So I could go ahead and simplify this even further by saying, since I'm using context.scene, let's just say scene equals bpy.context.scene. And then down here, I can take this down to just scene. And why don't we do this one more time and say that selected equals bpy.context.selected objects. Because then going here, and I simply say for obj in selected, that then gives me my list. And so this is really, really clear, whereas previously it was not. Now, this is not really necessary because even before, my code was still pretty simple and it wasn't a big deal because it was just a few lines. It was 13 lines of code, or actually, no, it would have only been like 10 lines of code approximately. But you can imagine that as we start getting more and more code in here, doing more and more things, that can become a lot more cumbersome. Particularly, if we're referencing operators all the time, it starts to get a little cumbersome to write out bpy.ops.object all the time. And so this is just another time saver. So running this is the exact same thing as what I had previously. Okay, so I think that's probably a good stopping point for now, but let me just go ahead and show you an additional version of this same script where I took it a little bit further, and it's not a lot further, it's just a little bit further, and go into object add-subsurf.py, and you can see I did a couple more things. So first of all, I have a for loop, which is the same as what we had before, that finds our object. Then I assign the active object, just like we did before, and I add the modifier to it. But then I want to do two more things, and that is, what if we already had a Subsurf modifier on? Then I want to be able to account for applying all the modifiers. So if I already had a Subsurf modifier on, it actually wouldn't apply my new modifier, it would apply the old one, assuming that I had never changed the name. So what I can do here is I can add an additional for loop within the for loop. So it's going to run this loop inside, or for each object within this list. Because each object, or the modifiers within each object, is another list. So I can simply say, hey, for my current object, look through all the modifiers, and then do a conditional if that modifier equals the type Subsurf, and I use a double equal sign here because I'm checking what is the value, not assigning the value. We're here when we use a variable, we are actually assigning the value of bpy.context.scene to scene. Whereas down here, I don't want to assign Subsurf to mod.type. That actually wouldn't work. I want to check, is the value of mod.type Subsurf? And if the mod.type is Subsurf, then continue on and do the next indented block of code. And so if the type is a Subsurf modifier, then I'm going to increase the level to 2, but I'm no longer using the exact name. Instead, I'm saying, hey, for this modifier, simply do mod.name, because it's doing one modifier at a time, and increase it to 2. So mod.name grabs the current modifier within the list that we are looping through, and then simply says, hey, use whatever the name of that modifier is. So this is a referenceable, I don't know the exact word, but basically a referenceable variable within Python that is just auto-assigned to that modifier, allowing us to access it. So mod.name.levels equals 2, and then it goes on to object.modifierApply as usual, but again, the modifier is set using mod.name rather than an exact name. So this way, no matter what the modifier is called, so long as it is a Subsurf modifier, it will work. And this just gives you extra flexibility. So if I go ahead and just say add in a Subsurf modifier, and let's just name this test, and then I run my script, it's going to add another Subsurf and apply both of them. So if I hit Alt-P, you can see both of them have been applied, and there we go. I have a nice subdivided cube. So in this case, this is not necessary because you may not want to apply all those. But you can start to see where if I wanted to always say apply all Subsurf modifiers, then I'd want to do that. I want to use the mod.name type because that way it's not hard-coded. My code is a lot more flexible. And in fact, I actually did that on one of the add-ons that I've used multiple times in some of my tutorials called JTools. And this is, again, an add-on that you can get from the CG Cookie GitHub repository, which I'll link to in the description for this tutorial. And in this JTools, which I can bring up via Q, I have this ability to apply a Subsurf modifier. So if I choose Add Subsurf, it adds a subdivision surface modifier. And let's just rename this again. So since I've renamed this, if within my next tool, which is called Apply Subsurf, if I had hard-coded the name, that would then fail. But if I'm simply checking, hey, for all of the modifiers within my object, if the modifier type is a subsurf, simply grab whatever the name of that subsurf modifier is and apply it. So now doing Q and apply subsurf, it just works. So that just allows you to have a lot more versatility and flexibility within your code. And I think that's probably a really good stopping point. I know that this was a little bit of a crash course of sorts. It was pretty quick. But I am working on a complete introduction to Python for beginners in Blender. If that is something that you're interested in, please do go ahead and show your support in the comments. It's going to take me a little while to put together. I'm want to be sure that it's really thorough and that it's not making any assumptions. So if any of the things that I talked about in this tutorial, whether that was variables, for loops, conditional if statements, whatever that was, if any of those things confused you, do be sure to call it out in the comments. I'd love to hear, what was it that confused you and where did you get caught up? And that way I can be sure that I'm answering all of those questions with no assumptions in the course that will be coming soon on an introduction to Python for beginners in Blender. That will be a citizen course, but it'll hopefully be really thorough. I've been working through it for a while, and it's something that I've wanted to do for a long time. So if that's something you want to see, please do go ahead and raise your hand in the comments, and I look forward to seeing you next time. Cheers.